All right, I think we're good with the recording. So, all right. So before I get started, I'm gonna do a small overview about like the Network Plus. So we just finished the certificate. We just finished A plus certification. So I'm just gonna do a small overview for the new start that we're gonna be starting and just give you some some insights into what will be expected in the exam and how the exam will be. So this specific certification is a little bit shorter than the A plus. It does not have two sections as the A plus, so thank God. And it's actually built up on one of the sections, if you want to say, or the domains that we have for the A plus, especially for section 1001. Okay, so that's built up on that in general. Let me share my screen and right here. Okay, give me a second. Let me check here. Sorry, let me connect this. One sec. Sorry, my phone, my computer was gonna turn off. All right, so let me share my screen. I think someone has. So I'm just gonna mute that. I'm not sure who's the iPhone. I just muted you. Share screen. I'm gonna share my screen here. All right, so this cert has 5 sections. The main section in here, or like if you want to call it like the biggest section, is the networking concepts. I tried it to the way I'm going to go over in this class. I will divide them into each concept separately. Majority of the concepts you already seen them, you already know them. We're just gonna kind of like go in depth into what they are and try to explain them a little bit better. But majority of them have been already addressed in the class in the previous class, as you know, in the networking section for 1001. Then we're gonna go into the infrastructure, networking operations. Of course, the network security is just this one is similar to the security portion that we had in 1002. And then again, networking and troubleshooting, how to troubleshoot a network. We're gonna go into some commands and how to find out what is like the connection being dropped and things like that, and how to do a trace route, how to trace a network connection. Um, any questions before we move on? Let me go ahead and actually start this. All right, so let me open the chat just in case someone has a question. All right, sorry. Okay, I'm gonna open the chat. So this small box that you see in here is just the chat, just FYI, because I had questions saying like before what is that? So let me go back and bring the. All right. How do you guys like the schedule? Is it good for you? You guys are okay with it? Good. Okay, that's good to know actually. Love it. Yeah, thank you. Yeah, it's good. All right, so let's go ahead and share the screen again. All right, perfect. All right, so this is kind of like the first chapter that we're gonna go over. So we're gonna go over like introducing a network in general. Again, this is a lot of the things we're gonna go over, we're gonna just be glancing through them because we kind of like know what they are. Um, so what is a network? So a network is basically just a combination of computers getting together, or computer or hosts, if you want to say, it's one or well, two or more hosts getting together to create a small network to share. The purpose of this is to share data, to share information. Whatever data could be voice data, it could be like a regular, data that we see, whatever protocol they use, whatever thing. Basically, a network is just the connection of two or more things together. Um, then the one thing that we have to understand very well is what's a lane, right? Um, I'm sorry, question? Yeah. So a lane, or like what we call a local area network. So it's basically let me see. Someone is being unmuted. Sorry, let me. Yeah, please mute yourself. Okay. All right, I think we're good. All right, so a local area network, it's basically just your home could be a local area network. You should, for the purpose of this certification, you should be able to know how to define a local area network. The way I will say how to use it, how to do it, is utilize the router, right? So a router, it's kind of how we can define that local area network. So every local area network, it's defined by a router. Use that router as a guidance, if you want to say, or as like as a tool to be like, okay, to be able to define what's a local area network versus what's what we call a a WAN, or like, as we're gonna see, like what's a PAN and things like that. So we're gonna, for a local area network, it will come a lot on the exam, where they will um, give you like multiple local area networks, and they'll tell you, okay, define which one is a local, which one, how do you define the whole thing, or they may like highlight the specific structure like this, and then tell you what is this one, basically. To always look for that router, and then we'll go over some signs as well, like to explain to you guys before the exam. Each sign, what does it mean? For the router sign, for the switch sign, like when you see a switch is like this kind of computer, like server. So these um, you need to be familiar with these as well, to be able to see what they are. All right, so this is kind of like the lane connected together. So this is the router that connects them. So they're putting them as a whole. This one is a lane and this one is a lane, but technically speaking, this is a lane, right? If they're connected to a switch, they could be considered like a local network, local area network, uh, just like within here locally, right? And this one will be local area network. They'll all connect to a switch to get out, but they're all like separate. Right. So this is understanding, the differentiation between, or a host slash workstation communication to the server. If you hear the host, okay, the word host or the word workstation. A host is anything on the internet. Okay, so describes like pretty much anything that has an IP address could be a host. So your cell phone could be a host. We don't call a cell phone a host, but you could it's technically it is a host, right? Anything that has an IP, right? You can describe anything, pretty much anything that takes an IP address, right? As a host. So anything you can access is a host. A server is a host. Computer is a host, right? It takes an IP address. A router is a host, right? So you need to understand how these terminologies, you need to be familiar with them. So when you hear the word host, that's what it means. All right, so what's a wide area network? So a wide area network is usually defined by multiple routers, right? You need like a combination of routers together to create a wide area network. Now, for the exam, they may try to confuse you by doing one thing, and then I want to make sure that you guys understand this, where they put something like this. And because for us, like normally, as when people teaches like a different, when they teach, like the differentiation between a wide area network or a local area network, one of the things they actually always emphasize on is they give examples with cities. They say, hey, a big city is a wide area network, right? But that confuses you as as a student, because this is actually a wide area network. Imagine this is being a house, like for example, like I will say, this is Marwan's house, this is Rishak's house, right? There are two houses, but they're all both together, coming together, they create a wide area network, right? Why? Because they're two routers. There are two different routers in place. So that's how you define a wide area network. But like I said, it creates that confusion because you look at it as a huge city or something. Yes, a huge city, it is a wide area network, but what is the smallest way to define it? It's like what we see right here. Okay, and just to make sure. Okay, so
A
question?
question?
Yes, sir.
Yeah. Uh, so you mean that any network more than one router is known as wide area network?
Correct. Two or more routers could collectively create a wide area network. Yes.
But isn't it? Is it only depends on the router, or it depends on the size and the space and distance of the network?
Okay, you can define it on the space and on the size of the network. You can do that. However, um, if I give you two, if sorry, let me do this. If I give you this, if I give you two connected together here to the internet, these two. So what would you call this network right here? Yeah.
Basically, if it's like very near to each other, or let's say in the same building in the same area, so we could say it's a local one. But if it's like a very wide area, since the name is wide, which means that it might be more than one spaces or one location. At least if we compare it, or if we evaluate it according to the destination, so maybe more than a kilometers, then we could say it's a wide area network. But in such situations, obviously, if they are in the same house, as you explained, like in the same building, or let's say in the same floor, so it could be a local area network.
So, and then, okay, so if you call these a local area network, so this one by itself, it's going to be a local area network, correct?
Yeah, each of them could be a local area network,
And then
and
all together is
then
a local area network?
we can call him a wide area. But I mean, but
No,
my
I see what
question
you're
is not
saying. No,
about.
no, I got what you're saying. No, it could be both. I mean, it's misleading. That's what I was trying to say like earlier. Yeah, it's a wide area network. It spans like a greater like a big, like here, like it says, big geographic area. There's a large geographic area that it's covering as a wide area network. However, when they give you stuff on the exam like this, they may try to trick you as well, because this one is considered a local, but a combination, like as a definition, it is, you can think about it in the geographic way, but also you got to think about it as also like multiple routers getting together to create that wide area network. So if they put a lot of them together, they technically, not to the definition, but technically, it's basically a wide area network. To the definition, I agree with you. It's basically like it spins like a wide, like cities, right? So spinning like, for example, like I don't know, Virginia, Maryland, DC, that's a wide area network. But as
But
in
we
the
al-
certain,
but we also have but we also have one more type of network, which is bigger than
metro,
local and smaller than wider.
excuse me, you said you were breaking up. Probably it's just my speaker.
I
But
said
what were you
I
saying?
said we also I said we also have another type of network,
Yeah,
which
yeah.
is
There's
bigger than
multiple.
local,
Yeah, yeah. There's
bigger than
multiple.
local.
Hmm. Yeah, yeah, yeah. I agree. Yeah, there's also like something called like a metropolitan. Um,
Yeah,
correct.
exactly. So
Yeah,
So
correct.
I mean, maybe the if we use more than a router, like two, so if we explain metropolitan, so maybe it works on that. But basically, if we go for the wide, I don't know. As per my perspective, the way that I have learned before, also from different theories and different definitions. So they are going basically for the wide. They are valuing the distance more than the size of the router or the number of the routers that they use in a network.
Yeah. I see what you're saying. Yeah, that's fine. I mean, if that's how you wanna that's how you want to take it, that's fine. You could really again, it's just like I said, it could be confusing a little bit um about like what's a wide area network versus um what's a local area network. It's kind of like they're it's kind of like the same. The metropolitan, it's literally like it's like a size saying, when you say, for example, like just New York itself could be metropolitan. Yeah. And the metro area network, yeah, it's a metro basically. Yeah. Yeah, so saying, yeah, exactly what you said on the chat, Maron. Yeah, they're pretty much the same. Yeah, okay, it's just like they spin it into an area. So basically, like when we say like a wide area network, a local area network, it's saying basically locally. However, when you bring multiple routers together, you create something. You create like you don't create a local area network. It cannot be defined as a local. You know what I'm saying? But it is right. It's confusing as it could be, but it could take it with the geographic area. So definitely. So yeah, sorry for the confusion. All right.
Yeah,
So
it's just confusing. So we have to remove the confusion because you know that if it's an exam question, so we have to be fully understand that from which dimensions we have to go to answer the question if such questions come to us.
yeah, because if they give you, because they're not gonna give you if it's a build, they're not gonna tell you if it's a building, or they're gonna give you something like this. You see what I'm saying? And as long as these IPs are different, they're different subnets, that means they're different local areas. So that's kind of like what they will look at it. It's like my house is a local area network because my subnet is different than the next house subnet. But yeah, all of us together would create a network. A whole neighborhood, it's a wide area network because we're all a lot of networks connected together. It's multiple networks, and again, that's why I said it's gonna be misleading. And as we see questions, you'll start like getting familiar with the way they will ask you questions about these terms. All right, so all right, so each again here like the MPLS, so network local connection. So basically, there's something called the corporate office, right? And then there's the branches. The branches are us as the users, right? We are the branches. And the local area network, I'm sorry, and the corporate, I keep saying, and the corporate network, or we call like the also internet service provider, right? ISP, right? This is a word that you may hear. I'm going to put it on the chat. So internet service provider, it's also like you may see it in there. So it's ISP, right? So so the ISP basically, that's what assigns or labels, if you want to say, the data head. So basically saying this is a local area network. So they all gets the network from they all get the network from the corporate office, right? The corporate office is creating a link, and all us as a branch, like if you remember, think about this local office being an actual um, think about it when if you come to a whole neighborhood and there's like a small box if behind the neighborhoods, and when you ask them to connect the internet for you, what they do is they will come and they'll start your house, they connect the cable straight to that box. Think about it just like that. So it's basically you have a corporate office box and everybody comes in and starts putting their connections in there. Okay. All right, so there's something we call peer-to-peer networking, and this is basically a direct connection between, for example, if you have here this example right here, you have Millie, Mike, Luis, right? So these are basically creating a networks together. So there's multiple networks, right? A peer-to-peer connection is just a direct connection. So I can have this connection link straight to Nikki, for example, or to Louis, right? So a direct connection or a peer-to-peer connection is just a straight through connection between two devices or two hosts, if you want to say. All right, so a client to client server network. So this is basically where all of them, they can connect directly to a server, right? That's what we call a client server. So peer-to-peer is basically a direct connection Client server is basically the clients are being connected to an actual management server. And then we're going to go ahead and start talking about topology. So topology, there's multiple topologies that we're going to tackle in this class. The main topology we're going to talk about is something called the bus topology, right? So the bus topology, it's just think about it as multiple like hosts. Hosts are getting connected to one line. So there's one line, they all have direct connection to the line. Right, and this topology, they may ask you about it. They may give you, for example, like something like this and tell you what type of topology is this, right? So you need to understand what type of topology they are. So there's here, if you see, they're all connected to one line. So there's like a backbone connection. I'm sorry, wait. Wait, I hope can have more. Yes, it could have more. It could have up to 8 ports. I'm sorry, up to 6 ports. Sorry. Yep. Yeah.
Is this a fast topology?
Sorry?
Is this a fast topology?
A past topology? I didn't hear you. Sorry. Go ahead one more time.
Fast. Is this a fast topology? This the type of topology for this?
This is a star topology.
Okay.
Yeah. No, I'm sorry. I was answering a question from the chat. Sorry. Fast topology. Oh, okay. Yeah, no, it's not. It is a fast topology if you want to say it's fast. Yeah. Yeah, you can say that. Yeah. But star topology, it's basically all of them are connected to a local either switch or a hub or a router. The differentiation between these two, here we're connecting to a backbone. There's a line connection, a line of connection. Think about it like a line coming straight from the ISP, right, Internet Service Provider, and then we're all connected to it. We're all directly connected to that line to get access. Here we're connected to a central, there's the star topology. Think about it having a central connection, right? The ring topology is different. Okay, the ring topology has a lot of falses that I want you guys to see in here. If computer A here is kind of like think about it as like having a hub, right? How would the hub like send any communication, right? The hub will basically he will broadcast the information to everyone, and whoever that information is for, he will contain it and use it, right? So this is kind of like the same thing. The ring will go through every host in the network to access the designated host. For instance, if I have, for example, computer 1, 2, 3, 4. So 1 wants to talk to 3, right? He will have to go through 2 and then gets to 3. He will not just go straight and have a straight connection. That's the differentiation between star and between a ring. A ring is like it has to go through multiple hosts to get to the designated host. And then we have what we call a mesh. A mesh is just like I always think about it. A mesh could be, it's basically having multiple connections to the host instead of having like a ring or like a star, a direct connection. This one is having multiple connections. Like there's multiple ways to access this host, for example. If this host wants to speak to this host, he can have a direct line. He can go through others. He can go through here and then jump in here. It depends. There's multiple ways to get to that person, to communicate between hosts, and that's kind of one of the beauty of having the mesh topology. All right, this is what we call point-to-point topology. The point-to-point topology could be either through you will see it through wireless or through like wired Ethernet connection. It will be either like a straight through cable, going from your host to the actual hub. Yes, point-to-point is definitely 2 devices. Yes. It's a direct connection. It's like host to host or host to hub. Got it. Yep. Point to multipoint. It's like one to many relationship, right? So it's a one to, this is the corporation and then multiple branches of the office. It's one to many relationship. That's kind of point to, when you see point to point is like one to one relationship. When you see point to multi-points, it's one to many relationship. Okay, so again, point to multi-point. And then we have a hybrid. So a hybrid, that's kind of when it gets a little bit, again, a little confusing, okay? Here, when we have a hybrid, we're having basically a combination of two. It could be a star and a buzz. It could be a mesh and a ring. Oh, no, a ring could not be a mesh. But it could be a star and a mesh together, creating creating basically a topology. And this is what we call a backbone. A backbone is basically everybody connected to this link to get connections. Like think about always when you see a backbone, think about it one line of connection. Like think about a physical line. Think about this, a physical line, okay? We have segments. You have direct connections through through that line, right? And then every direct connection has, like we call it, the fruits, the layer of fruits or the layer of hosts. So these are those layers, okay? But we have a direct connection, a backbone connection through everything. All right. Any questions? No questions?
Which of these types are more usable at the moment?
The mesh is more useful. If you look into the network map within the United States, they use a lot of mesh, topology. Yes, mesh, and there's also like the second use will be start. That's another one that's being used a lot.
Can you go over mesh again, please?
Yeah, so mesh is basically, just think about it as multiple. It's like literally like a mesh, but it's like, multiple devices don't have just one direct connection. That's why the mesh is being used a lot. For example,
but you said there are lots of faults in this type of topology. Like, there are, if let's say if a network is want to send information to another designated network or another.
No, I was talking about the ring.
Oh, you're talking about the ring?
Yeah, the ring, because you have to go through others in order to get to a host.
And even if you see on the structure of the mesh, can you go back? So, don't you think like there would be a let's say interjections with the transferring data in the same time? If it goes from one network to another network, something happens in between according to the structure.
The way the mesh is structured is to have more than one direct connection, and more than one way to connect to another host. That's what they're trying to do.
You mean if there's a traffic in one side, so they automatically
and if there's a broken if there's a broken line, and then we're gonna talk about when we talk about like the routing protocols that we have, when we the way those routing protocols will work perfectly, it's because they have multiple ways to access a host. So it's just not one direct line, one direct way. Like for example here, if this line breaks, right? If this line breaks right here, I have to go through this. If for example, this is my only spin, this is how my ring spins, right? If I break this line right here, there's no way I can communicate with anything. So I need to wait until that line is being restored, until that connection is being restored. However, on the mesh, think about it. If I break this line right here, I can deviate here and go here. If I break this line right here, I still can get to this guy basically by going through another host or by going through here. That's the beauty of a mesh. There's multiple ways to communicate. That's what makes it used a lot, because the fact it simplifies our connection.
And the connection between these would be wireless or wired communication.
Oh no, don't think about that yet. I don't want you to do that. No, that's gonna confuse you. It doesn't matter what it is. Think about it like that. Right now, we're talking about about topology, because it's gonna confuse you, because you're gonna tell me, "Well, I don't need the connection. I'm wireless." Nah, don't go there yet, because it's gonna create some confusion. But think about it I mean, we can think about it just a link as a direct link. Here, what we're looking at, I just want to specify a little bit more. What we're looking at is, think about your router. Okay, I don't want you to think about your devices connected to your router. Think about your router, my router, Fana's router, Miran's router, your Shaq's router, your Cease router. All these router, how could they connect to each other? They have a cable connection, right? They have a certain cable connection between all of us. So they cannot have a wireless. Your router does not wirelessly gets that connection, right? There is a cable going through. So the basics, that's what I'm trying to say. The basics of everything is a cable. There is a cable that's going to bring that juice to that router in order to start. So that's why I said don't create that confusion, because you're going to start thinking about it, because we're looking at, right now, we're looking at a topology. It's not as, your house, my house, but or small devices being connected. We're talking about bigger picture, like that wide area network topology. They all have those cables. So all of us, if let's say all of us live in the same neighborhood, right? We all connect, right? We all excuse me. We all connect to the same office box, right? That's a physical connection. That's what I'm trying to say. So think about it always when you see these topologies as a physical connection for now.
Topologies, or it can be between two routers, it can be between switches, or it can be between the computers.
Routers, topologies, yeah, it could be between all of them, yes. But it's gonna confuse you if you think about wireless as you're looking into topology, yes. Because you're gonna think about wireless, but you're gonna forget that they're all this wireless to work. They're based on what? They're based on a cable connection, right?
Cable, yeah.
Yes, that's why I want you to understand. Because if you may get a little confused if you keep thinking about wireless, but because the main thing in here is a wire. If you don't have a wire, there's no way you can even have that wireless or that access point or that router, right? Yeah.
Yeah, that's fine.
Yep. All right, so let's move to another. So like I said, I broke down the CERT into multiple topics, and I will share with you guys these presentations as well after the class. But it's basically for you guys to start understanding, but we're going part by part, little bit by little bit. So we're gonna, gonna go here. I'm gonna share this with you as well. So open with. Let me stop sharing. Gosh. And then there's I think the biggest part in here, just an FYI for all of you guys, it's gonna be literally understanding the actual, what we call it, the actual subnetting. I think subnetting is one of the biggest challenges when it comes to, to the whole network plus, right? So, all right, so let's move on a little bit. And the next topic will be the IP addresses. Okay, so it's going to be literally thinking about the configuration, broadcast versus multiple domains, multicast versus a unicast. All right, so let's do this. Any questions before I move on? Does anyone has any questions? No? Okay. Let me grab the chat again. No. Okay. All right. Perfect. All right. Let's go ahead and continue. All right. So this is kind of like one of the, we're gonna talk a little bit about this terminology in a little bit, and then see how we're gonna put it into use, if you want to say. So what a bit? What is a bit? If I ask you guys, what's a bit? I mean, I think we talked about this, but what's a bit for you guys?
Small piece of information.
I'm sorry?
Basically, the meaning is a small piece of information, but bit is it's information that's on the primary level of the when we collect data, sending from the first level to the second level. So as a binary code.
Yeah, so it's a binary code. Yeah, it is. It could be a piece of data when we talk about computers. So a bit is basically it's either a 1 or a 0, right? That's what I want you guys to understand. So 1 bit, if you guys remember when we studied like A plus, so we saw that a bit could be either a 0 or a 1. We talked about what's a byte. So a byte is 7 bits, right? So if you guys remember this, and as we go to talk about about like how you do subnetting, and that's going to be the topic that we will spend about like a week on it. And I think that's going to be starting next week, because I always start early on subnetting, because the other stuff, it's easy to just run through it, but subnetting takes a longer time, and that's why I'm going to be going through next week. But that's why I'm getting you guys to this right now. So a bit, like I said, is just a 0 or a 1. A byte is binary digits. 8 digits. Correct. Yes, exactly. So a byte, yeah, I'm gonna put it for you. So a byte equal, right? This is a byte. So it's basically 8 bits. I don't know from where they got 7, right? And the bit could be sorry. Wow, I can't type today, I guess. It's either, excuse me, either 0 or 1, right? An octet, right? An octet is basically, it's also 8 bits, so we call it an octet. So octet equals 8 bits, right? So what's a network address, if I ask you guys? I mean, don't read that. What's a network address? What defines us as like a device in the network? What defines it?
Network address, NIC. Network address is an address where every device is given in order to share information or internet with each other. So basically, there is a network IT card inside the device where it can pass the networks between each other.
Yeah, so a network address is an IP address. So that's kind of like it's your like Ishak said, it's your IP address. That's what defines you in a network. So for us, when we get into the network, the only thing that put us different from each other, the only thing that differentiate my computer than your computer, then let's say I'm gonna keep again referring to us as a group, as a team in here. It's your address, yeah. Well, your MAC address, it does at the lower level. See, where does the MAC address comes through? Which layer, guys? And then I'm gonna keep throwing layers at you.
On the second layer, it's a physical address.
It's a physical address, but it comes in which layer?
Second layer.
Second layer, okay. So who can tell me what's that second layer? Tercet, what's the second layer?
I forgot the name.
Data link, yep. Thank you, Tercet, thank you. Yeah, so it's data link, yes. So it comes data link. Good, data link. Yeah, no, that's good. I'm gonna keep throwing these at you guys all this, I don't know, 5-6 weeks that we're gonna finish the certifications. You're gonna hate me and you're gonna hate the OSI model, but I'm gonna be throwing it all the time at you, and then I'll just single out one of you guys to tell me what it is, okay? And it's not I'm not trying to trick you, but I want you to know it by heart. I don't want you to have to go over. Yeah, I don't want to go over the actual OSI model again. I'm not gonna go over it in Network Plus. There's a whole chapter just about the OSI model. I'm not gonna go over it because we already should know this by heart. I want everyone to know the OSI model by heart. And as we go, we can be talking about IP, and I may throw something and be like, hey, so where do we find the switch? Where do we find the router? What layer does a switch function on? What layer does a router function on? Right? So these questions, you should expect them all the time during these 5 weeks. Like, we were a little bit babies. We learned how to crawl. Now we're walking. So as we're walking, I want you guys to start understanding things, be on top of your mind. It clicks when you hear the layer 2. automatically know it's a data link. Right. So yeah. So and then we know what's the broadcast address. Basically, it's used basically for by the router to broadcast to see, hey, I'm here. I'm on the network. I'm right here on the network. So it's basically that's how they use to locate any host on the network. They use something called a broadcast address. We're gonna know a lot. We're gonna talk a lot about how the broadcast address works and things like that later on this chapter as well. All right. All right, so we're gonna talk about an IP address. Who can tell me how it's in there? Okay, who can tell me how many bits is an IPv4 have?
32 bits.
Okay, yes, that's 32 bits, correct. So IP addresses is divided into 4 octets, right? 4 octets. There's a dot between each octet, right? Right? So there's a dot between each octet. Each octet we said is what? It's 8 bits. So we have 8, 16, 24, and 32. 32 bits is an IP address, right? And an IP address v4, it's in a decimal. This is a decimal way of putting the IP. It's what they call it the dotted decimal. This is a dot between every decimal. What is the maximum we can have on an octet?
172.
No, the maximum.
256.
255. Well, it is 256, but from 0 to 255, that's what you can
Yeah, I
have
got you.
as a number. But it is 256, correct? Yeah. I like it. I love it. All right. All right. I'm sorry. I got here. All right. So we talked about addressing. So we said every host on the internet has an IP address, right? An IP address is just like saying you have your own address, your house, and or my house, or your Shaq's house, right? We all of us have an address, and this is kind of like what specifies us, or what tells where we are as a location, as a beacon. This is each of our address is our beacon. Like if I want to send something to Ishak, I'm going to send it to his address. Now, if I want to communicate with Ishak, I'm going to use the same thing, my computer and his computer. We're going to communicate through I need his IP address to be able to communicate with him, right? When we talked about IP addresses, we classify them into classes, right? We said we have the main classes that you need to remember all of them, but the main classes that we're going to talk about and we're going to start breaking down it and then using in the subnet, it's class A, class B, and class C, okay? These are the 3 classes, and I'm going to specify each one what it has. What I want you to remember is this view right here. Think about it. We have a network, and the host. So let's go from the beginning. I'm sorry. For a class A, the first 8 bits, the first octet, it's the network. The last 3 are the hosts. What does that tell you? How many hosts can I have then? And how many networks can I have?
We can have
Go.
we can have 3 hosts, 1 network, or 3 network, 1 host in each class.
1 network, 3 hosts.
1 network. So we have 1 network in here? Yeah. Or how many networks? Okay, so we have multiple networks in here. Think about it. Look in here. We have how many numbers could we have in 1 octet in 8 bits? How many numbers could we have?
32.
Not 32. You got it. Not 32. And this octet 8. Right here, this 8 bits, we can have 255.
8.
So we have 255.
Oh, 255, yeah.
Yeah, 255 networks, right? That's how many networks we can have, right? And then these are the hosts for each. So for each network I create in here, it has what? It has 24. It has what? So this is 8 and 8, 16, 24. It has 2 to the power 24 in terms of hosts. And I confuse you probably right now. You guys follow this? Oh, please ask questions. I mean, this is kind of like we're just laying a little bit just a layer of, let me put the chat in here so I can see. Okay, and then also I need to get this because I think need to mute. Okay.
Oh, okay.
You get, okay, who's following me here and who I got lost at some point?
Keep going.
Tercet is the only one that got me. Who, okay. Okay, Ishaq is following too. All right, I got it. Now I know you all here. I just want to make sure who's following with me and got what I'm saying. But I got you. I know you guys are with me here. All right. So what I'm trying to tell you here, so it's basically here we have, think about it, 8 bits. Class A utilize the first octet of the IP address to classify a network, and then the rest for the hosts. So basically for class A, I could have 255 networks, right? Each one of those networks will have 2 to the power 4 of hosts possible, right? 2 to the power 24 of possible hosts that you can have for each network. So any IP address for with the class A, right, will have 2 to the power 24 hosts possible to connect to it. For the class B is different. Class B, it's kind of like a half and half. It's 2 to the power of 24 for hosts. Yes, for class A. Okay, think about it for class B is different. We have 2 to the power 16 for network and 2 to the power 16 for hosts. Every network I select from class B will have 2 to the power 16 of hosts. So think of how many hosts you will be able to have. When it comes to class C, it's different. It's a different view. We're talking about 2 to the power of 24 just for a network, right? You can have multiple network. Each network will have a small number of hosts. What does your house will have normally? Your house network. What does it have? Does it have A, B, or C? Technically speaking, I mean, normally you don't use this for
A.
no, tier C, correct. C. You'll have a C. Because you don't need 2 to the power 16 of hosts. You only need 2 to the power of 8 of hosts. You don't need that many hosts to be in your house. You don't get to 2 to the power 8. So you don't have more than 255 people in your house that connects to your internet. Right? So yeah, so C it is. So when you think about classifying the network, right? When we about classifying the IP address, we have 5 classifications. So A, B, C, this is the main thing, and we're gonna keep talking about this pretty much the whole class, if you want to say. Oh, who's that? Sorry, give me a second. I literally, okay. So A, B, and C are basically the actual classes that we're gonna be really talking about. So 192.168.0. Correct. Yeah. And for D and for class D and class E, the multicast and the research, those are something we're not gonna touch. We're gonna know where they are, but we're not gonna touch them. Okay, we're not gonna do anything with them because that's not something that we're gonna be subnetting. These are private. That's what we call the actual private addresses. So class A, we already talked about it. So what you need to take from this is network, host, host, host. So 255, remember 255, 255, 255, right? So the way we represent this class A is 255.0.0.0. Okay. For class B, 255, 255.0.0. That's kind of what we call the subnet mask. 255, 255, 255.0. Right. That's our first host, right? The first host will have 0. The second host will have 1, 2, 3, and you keep going like that. Any questions? No question. Okay, so we talked about like a reserve IP, and we're gonna make sure that we understand a little bit. We're gonna kind of elaborate a little bit more. This is the reserve IP, but there is more into it. So the first reserve IP that we're gonna talk about is the 0. So 0 is always, you know, it's always referred to as the 0 network. So it does not get assigned to anyone. Then we have the number, the IP address of 1. The 1 network means all the networks. If you do 1.111, that's kind of like all the networks together, right? 127, if you guys remember, that's for troubleshooting. That's for what we call a loopback address, right? We use it to loop back, to do a loopback test, to basically just check for a local host if it has internet, if it has connection, right? And then we have something also called 127. Well, it is this one actually. The 127 is for the loopback. And we also have something called the 255, 255, 255, 255. That's a broadcast. That's how you broadcast to the network. That's a broadcast address. All right. So for our private addressing, and what we need to remember, and this one you need to know it literally by heart. It's these are the actual reserve that they will ask you question about. So if you guys remember once, I think these have been provided to you before, but Tercet once asked us that one of the questions says provide IP addresses, and they asked her which one is a private IP, right? So these are the private IPs that you have. So 10, right? We have 172 and 192.168.0.0 to 192.168.255.255. So these you need to know them by heart because they may ask you a question and tells you which of these IP is a reserved IP. Okay, the keywords is here. Remember these in here because class B. Remember the first octet and the second octet are network. So think about it in here. So it's one. It's yes, it is 172. But if it's 172.1, it's not a reserved address. It has to start from 16 to 31. That's the only one. So if it's 172.33, would that be reserved or not? Anybody?
What's the question?
So if I have, so these are the reserved addresses. So if I give you this address, 172.33.0.0, is that a reserved address or not? I can write it down if you guys want to. No. Yes, Tercet, good job. Yeah, it's not. So 172.33.0, I'm sorry, .0.0.
No, we have to do submitting to find the reserve.
No, the reserved are already assigned right here. You can see them. Right here are the reserved address. So like, yeah, like Tercet said, no, it's not. Why it's not? You guys see why it's not?
Because the last octet is 0.
No, no, it's not.
Because it's a public IP address.
Correct. It's a public IP address because remember the private IP address here, it ends at 172.31. So 172.33, it's a public, it's not a private, right? It's after this number because this is when they will ask you the question. Think about this in here. In this octet, think about it here. In 172, how many possibilities on the second octet? We said we have 255. The only ones that are reserved is from 16 to 31. Anything outside 16 and 31, it's a public address. This is how they will form the question for you guys on the exam. They will give you 172. They're all going to be 172. One of them is going to be between 16 and 31, or it could be the 16, or it could be the inclusive of the 16 and the 31. And the others will be like 7. It will be, for example, like 172.1, 172.10, 172. 34, and then they'll have 172.16. You have to go to that 16. This is where this class B is where they ask those questions. These right here. Okay, that's why I want you guys to see. Do you guys see? Do you all see this right now? You see what I'm talking about? Everybody can see it.
Yes.
Yes.
Yes. Okay, you guys got it. Okay, Ishaq got it. Fana and Moran, you got it too. Okay. If you guys kinda okay. Let me know if you don't understand it. Like if so what they will give you, like think about it like this. I'll compose it. I'm waiting for yeah, go ahead, ask questions. It's not a problem. So they'll give ask me if you want, no problem. I'll put a question for you guys so I can explain it. But
No,
then,
it's okay. I want you to just finish so I can I'll
yeah.
just wait. It's okay.
No, go for it. Go for it. No, it's better to address it. Okay.
No, because I'm like just really lost. I want to like just wait. Like maybe it'll come to me. The pieces will start
Oh, okay.
to make sense. I'm not gonna lie. I'm still thinking about A plus. So
Oh, I know a lot of you guys are probably still thinking about A plus. That's normal. It makes sense, you know. It's just because that's kind of like where your focus right now is. That's why I'm not gonna start subnetting until next week, and probably I will give it, yeah, I'll probably give it like another starting it on Tuesday. I'll start on Thursday just to give you more time, because subnetting could be a little bit consuming. It consumes a lot of time and also a lot of you know, you're not gonna have enough time to go over your regular A plus exam or anything, because it's complex itself. So think about this question right here. Think about these IP addresses that I just put in here. Right. So this is how the question will be on your exam as well. So here you go. So they will tell you which one of these are private. I'm sorry, yeah, which one of these are private, so or reserved. You have the data right here. So which one is reserved?
The third one.
The third one, no, it's not reserved.
The second one,
The second one is reserved. Yes, yes. And and why the others are not?
because they're public.
Yeah, but why they're public? Why you they're public because they're see the second octet, they're outside the interval of 16 and 31. That's what they are. So because they're out of that range, yes, they're out of the range of 16 and 31 in their second octet. That's what makes them public. Correct. Yes, but yeah, you got the right answer. Correct. Okay. So what time is it? 35. Okay, let's take a quick let's take a quick 10-minute break. And then we'll reconvene in yeah, no, for sure. Yeah, no, go for it. Let's take 10 minutes. So we go 5:45 and then we reconvene at that time, okay? All right, guys. See you in a little bit. I'm gonna go grab some coffee too. All right, guys. I hope everyone is back. All right, let's go ahead and sorry, let me kick in this. Yep. Okay. All right. Okay, now we're gonna talk a little bit about Apipa, our biggest friend. Then we talked enough about it, but so Apipa is basically whenever your whenever your DHCP is not working, and you have no you're not assigning um a private IP, if you want to say, right? If you're not assigning one, and your DHCP protocol just decide to fail, right? This DHCP it's not working. Then the only way for your computer to communicate, and they want to emphasize, communicate locally, okay? It's basically by using Apipa. Apipa is a protocol that kicks in, and then it will assign an IP address from the range of 169, right? 169, and that normally it's the 254.0.1 to 269.254. 169 is a class B, by the way. The 255 to 254. So the client will be getting an IP address based on this with this protocol, and this IP address will only allow him to communicate locally, right? Apipa always kicks in automatically. That's why I want you guys to be aware of. You do not need to do anything. If once your DHCP fails, Apipa will automatically just kick in, and you will have you will have it sending you and it will be sending it to you a little bit around it will be sending it to you like around the same time that your DHCP fails. Like once your DHCP drops, that protocol is not working anymore, you don't have anymore the ability to assign automatically IP addresses, this protocol kicks in, right? And then you will know, because as this protocol kicks in, you will know that you're not able to access the internet. You're only working internally. So if we're all internally, let's think about it all being an internal network. I will be able to communicate with all of you, but I cannot get to any other website or anything that I wanted to access. Right? Any questions about like how Apipa works?
Can you explain a bit more?
Okay. What specifically you don't understand, so I can know where to focus, if you don't mind.
I just understand that it's a customized IP network where if you are not able to do an IP address, so automatically it gives you an IP address. That's what I.
Yeah. So Apipa, it's a protocol that basically it's assigned you automatically a private address. This protocol in Windows, and again, this is only in Windows, by the way, it kicks in automatically. These are two things that you need to know. It will initialize whenever your DHCP is not working. So we know that DHCP, right? DHCP, it's a dynamic way it's a dynamic way of assigning an IP address to a host. So whenever someone comes to your house, you give him your network key, right? The Wi-Fi password, and then he puts in the Wi-Fi password, and right there he's communicating and he's accessing the network and doing everything. How does he do that? He needs an IP address, right? We said everything on the network, in order to communicate, he needs an IP address. So in order to do that, they use DHCP automatically assigns this new person that visited you at home, he assigned him an IP address. Now, if this protocol DHCP fails, it's not working anymore, right? The only way to communicate internally, it's using Apipa. Once DHCP fails, Apipa kicks in automatically and assigns a private IP with this range to every host on that network. until the HCP comes back on. Okay. Does that make sense, Waze?
And how it happens? I mean, practically, like the host is going to give an IP address for each user separately, and the IP address would I mean, configuration would be separately for each user.
No, it will kick in automatically. You don't do anything. This is already configured on your computer as a default. So by default, as you connect your computer, you don't know how your IP address is being configured in your network, right?
Yes.
Correct. So it's the same thing. It's basically the same way. Whenever that protocol that assigns automatically an IP address fails, this protocol picks up and then he assigns you a private IP.
Oh.
Yeah.
So it's only like a backup for DHCP.
Correct. Yeah,
If
yeah. It's like a
DHCP
backup plan.
Okay.
Yes, correct. Yeah. It's only
I
for
got you
Windows.
now.
Correct. Yeah.
I got you. Okay.
Yeah. Any questions from anybody else? I think I know for some of you guys we talked about PIPA a lot, but anybody else has any questions to? No questions. Okay. All right. Good. Okay, so so we're gonna talk a little bit about layers and how the broadcasts happen. So when we talk about broadcasts in general, when you have, when you're trying to know how many hosts there are on your network and how many IP addresses are on your network, the only way to do that, right? The only way to do so, it's basically what happened to the network? Okay, I think I'm dropping my network. Give me a second, please. Yeah, I'm not sure what's okay. Oof, I thought it gives me an error about the connection. Okay, so the only way to know how many hosts are on your network, the broadcast, right? The broadcast sends an actual email, or I'm sorry, an actual broadcast to everyone. It's basically broadcasts to everyone, hey, who's online, kind of thing, right? It sends to all the hosts on that local area network. It sends them a, hey, where are you? Like a ping. Like, I'm here. Are you trying to connect? Then if they say, yes, I would like to connect, that's the handshake that's being established for DHCP to assign an IP address, right? We're not talking about actually the TCP IP handshake, okay? We're talking about different handshake. So it's not a TCP handshake. This is a DHCP handshake. So there is, it's basically 4 steps that we go to in order to assign that, right? So this is kind of like how you do. Oh, sorry, give me that. Okay, this is how you basically find out which IP, excuse me, which IP addresses to assign to which host, right? So once you broadcast to everyone, whoever is looking for an IP address, he will say, hey, yes, I would like to connect to your network, and you will assign him an IP. That's what we call a broadcast, right? A unicast is basically sent to you single out one host. You send in a request, or you send in something to one host. So that host, it's being singled out, and that's what we use a unicast, right? A multicast, it's sending multiple packets, right? Multiple packets to sent from a single source, transmitted to many, or sent to many different locations, or to many different hosts. So multicast is one to multiple, right? Unicast is one to one, like well, what we said, point to point. So it's one connection to one connection. All right. Any questions about that? About the whole? Okay, now we're gonna talk about IPv6. So how many bits is IPv6?
64.
No, no, it's not. How many do you guys think for the other folks? Okay, how many bits are on IP address v6 or an IPv6? Sorry, I think my internet is a little bit slow. So an
Is it,
Mhm.
in terms of what you're asking? So IPv6.
How many bits are in an IPv6? We said there's 32 bits in an IPv4. So an IPv6 is how many bits?
Oh, so it might be 128.
Correct. It's 128. Yeah, it's 128. So 128 bits. So we said v4 is what? Is 32. Right? And for v6 is 128. How many how do we represent IPv4 if any one of you guys could tell me?
The question again, please.
Oh, I said, excuse me. Yeah, I'm sorry. I said, how do we represent it? We said the IPv4 is 32 bits and it's in decimal. IPv6 is 128 bits. And then how do we represent an IPv6? So this is an IPv6. What is this representation? We said the other one is a decimal representation. This one is what?
This is a binary.
No, this is a hexadecimal.
Oh, hexa. Yeah. Okay.
This is a hexadecimal. So yeah, so there's actually a column and it's hexadecimal, and um and the hexadecimal for the representation and the way you represent this is basically you put in an actual 4. This is basically what we call an octet. So there's a column between each separation. This is what we call a hexadecimal representation. The hexadecimal, we'll go over what it is. It's basically from 0 to 9, and then number 10 it takes the letter A. Number 11 is B. Number 12 is C, and then it goes all the way to 15, and it goes all the way to F. And then we got to talk about that a little bit in details. But I just want you to understand. So it's IPv6, 128 bits, and it's represented in hexadecimal, right? So this is how it looks like, right? It looks like basically 20, for example, like 2001 column 0db8. Now there's a rule, and the only thing they will ask you about v6, it will be to show or to tell us how the representation is, right? How do you represent the IPv6, right? So for example, if you look at it right here, right? If you look at it, you see how they removed the 0 from here, right? So what they will do in here, for example, they will remove every leading 0. There is a way of creating this IP address. They will remove all the leading zeros. So this is a leading 0, and every 0 is in between. So I'm gonna grab this and I'm gonna try to a little bit elaborate on this. Okay, so let me grab here. That's not Okay, so all right. Okay, think about an IPv6 like this. So I'm gonna put 2. There's 2 important rules about how they will be putting in. So probably this is actually, let me grab this too. Sorry, give me a sec. So 2 copy, doesn't matter what it is. Okay, so and I'll keep the chat. Okay. Okay, here you go. That's good. So this one is an IPv6. Now in the exam, the way they will ask you questions around IPv6, they'll tell you which of the representation is right. So, and they will create something like this. There's 2 rules that you have to know. Every lead in 0 could be taken off, right? And the in between zeros could be represented by double column, but only once. Only once. So if I have, for example, this, I want to create it. The lead in zeros, we said we take them off, right? This is lead in 0, take it off. And then here, these 2 right here, give me a second. These 2 right here could be represented by 2 columns. Okay, you guys got it? Let me ask you this. Let me give you another one. I'm gonna create this. Okay, let me give you an IP address and you guys do the work. So all right, so who can give me the representation of this? And again, I can't put it for you in the chat. You can just copy it and create a new one. Okay, let me add actually. Sorry, give me a second. Yeah, I think next week we'll start using the board. Copy. Here you go for everyone. You guys can use it. Copy and paste it again, and then give me a representation of this IP address. So we said the lead in zeros could be taken off, and if there is a two consecutive octets of zeros, then they could be reduced to two double columns, like we just saw in here. So the 2 columns. Yes, yes, correct. They're assumed to be zeros. Yeah, not assuming it. Okay, so anyone could give me that representation? Let's see if you guys could. Anybody? Are you guys working on it?
I didn't get this.
I'm sorry?
I didn't get the representation, so I cannot do it.
Okay. Anybody else did not? I mean, I'm gonna go over it again. That's fine. Anybody will be able to do it, or you want me to explain it one more time and then give you examples? Yes, yes, I got you, got you. Okay, so the rules is what? It's every lead-in. So every lead-in zeros could be taken off. And the second rule is every consecutive right? Every continuous zero, right? There's the shaded column. Yeah, but you did not take off the lead-in zeros. That's what she did. So every lead-in zero needs to be taken off, and any continuous, every continuous with zeros could be represented by double columns. Okay, so for here, think about it. This one, there's something we can do about these zeros. Could we take them off? We said the leading zeros are on consecutive, every consecutive sets of zeros. So could we take off that one or not? Yep. Binyan, good job. Maron too, good job. Yes, you guys got it. Yeah, so this one, they're not leading zeros. So these are the leading zeros. Okay. Right? So any leading zeros could be taken off. If they're not leading zeros, then we don't do anything to them. We just keep them. So that's what you guys saw in there. So that's what we call the zero compression. Zero compression, it's basically we compress these zeros, and these are the leading zeros, basically what you see up front. Good job. All right, so do you guys get it? Waze, did you get it or?
I got it that we have to remove
The leading one, yeah.
the leading zeros, but the question here is that how we know that it's a leading zero?
How do we know it's a leading zero?
Yeah.
It comes up front. It comes front to every octet. So this is kind of like an octet.
It means any zero which comes in the beginning of every octet that needs to be removed.
Correct. Yeah.
Okay.
Yeah.
And that's the only thing how we do.
That's the only question they will ask you about IPv6, pretty much, when it comes to representation of IPv6.
Okay.
Yeah. Question. Go ahead.
So you know how there are consecutive zeros, like the two sets of four? You put four. How many colons do you put? Do you put two double colons or one double colon means?
You put two columns. So it's like 2 columns, like in here. Because I think you asked me if you put two double columns.
Yeah.
So you put two of them. So one column and the other is another column. So just two columns to represent all these zeros right here. Okay, Ishak, what was the question mark for?
I'm sorry, but I'm completely lost.
I got you. Hold on, let's bring you in. Hold on. So all right. So for IPv6 in general, they will give you a in the exam. They will give you a representation like this, okay? And they'll give you like multiple sub-representation, like this one or like another one and another one, and they'll tell you which one of these is the correct representation of IPv6. The only way to know, right? The only way to compress this, you have to compress the zeros, right? You compress the zeros through here, and then you remove the leading zeros. It's a different way to represent this IPv6, if you want to say. So for example, give me a sec. So if you go, yeah, so hold on. IPv6 practice. Right, and then we go to image. Then I'm pretty sure oh gosh. Yeah, I can't find any, but yeah, I was trying to find you at least one example.
What will we do without Google?
Nothing, man. Can't survive without Google. All right, let's see if we have an example. If not, I can create. Yeah, it's not. That's literally a whole course. Never mind. Because I'm okay. Here it goes, like right here. So, no, that's not the subnetting for IPv6, which it's not covered. Never mind. I'll put it myself then. I'll put an example.
Okay.
It's just a little bit hard. All right, so let me do an example. For example, they'll give you something like this. Let's stick to this one. Wait. Okay, this process right here is called compression. You're compressing the zeros, the zero compression. This is called the leading zeros. The whole thing, it's representation of an IPv6. So instead of representing it this way, like this is the formal way of representing it, the first one that you see here, right? And this is the other way of representing it, kind of like the short version of an IPv6. So the only way, this is kind of like how an IPv6 will look like. And they'll tell you, how would you suppress? Or how would you, which of the following, it's the correct representation of the above IPv6.
Hi.
So what you will do in there is you'll have to take the zeros, the leading zero. So it's just asking you which one is the correct representation. We said we have two rules, right? Just two rules. If there's a leading zero, we remove it. Here, do we have any leading zero? No, we don't. So 2001 stays. For this one, do we have a leading zero? Yes, we have one. So DB 8. We remove the leading zero, right? We have 3 C 4 D. There's nothing, no zeros, it can't be removed, so it stays. 012. Do we have a leading zeros in there?
Yes.
Yes, okay, so we're gonna represent it as 12. And then we have a first set and second set of zeros. These could be compressed and presented by double columns, right? Double columns in here. And then
double columns means the compression of 2 octo zeros.
Correct, yes. And
Okay.
then column, and then we have 5, 6, AB. So this one right here represent this one. This is just an abbreviation of this one. They mean both the same IPv4 address. Does that make sense, Isha, or?
Okay, so basically, so 2001. After 2001, all the zeros have to be represented by
the leading zeros, you take them off. The leading of every See, there is a
Lead.
column in the column, the lead in, you take them
Okay.
off.
Got you. Okay. Yeah. And the prefix, you leave it like where it says 2001. You leave that. Everything after that.
No. There is no lead in 0 here. If it was like this,
Yeah.
if it was 0, 2, then I'll take this off.
Okay.
There is only 2 rules: the lead in zeros, only the lead in zeros of every. So each one, right? Each one of them, if there's a lead in 0, we take it off. Right?
I got it now. I got it.
You got it?
Yeah.
It's confusing.
Yeah.
I have a question.
So it
Yes.
has 2 rows.
Thanks.
Yes, sir. Go ahead. No, I'm sorry. I think there was
let-
fan or
let-
something.
Me or
Let her to ask questions.
Wise?
Ladies
Okay,
first,
Wise can
man.
go first.
Wait, go ahead.
Okay, thanks, Rita. So my question is, why do we need those zeros in the first place? What are those, the ones that are above, like preceding the other numbers? Not the 2001, but the ones like the rest.
These right
Like,
here.
why? Yeah, all those zeros. The ones that, not those, because we leave those. We have to get rid of the zeros that's before the numbers, right?
Well, we need them. It's just that was a good question.
I'm just trying to understand because
No, you're good. You're good. I like it. I like the question. It's well, it's not we don't need them. Okay, it's not we don't need them. We do need them. However, and like what they will do, they will ask you a question in a way. They will say, "What is the shortest? Which one?" This is kind of like the largest way for presenting it. Instead, if they want to kind of like compress it and put it like in a shortened way to represent this IP right here. Because you see, like normally our IPs used to be what? It used to be like something here, dot something, dot something, dot something.
Yeah.
Right? And this is easy. But compared to this, imagine if someone tells you what's your IP address and you have to tell him all this.
Yeah.
And he has
So
to
this
type
is a
it out.
special one.
Okay, this is kind of like an abbreviation of this IP right here. So the way we abbreviate it, or the way we kind of like try to put it in a shortened version, is we apply these 2 rules. These 2 rules have been applied to the zeros. Okay, I'll put a practice sheet together. I couldn't find one online, but I was planning to find one online and give you an example, but I couldn't really find it.
Thank you. Yeah, I think
Yeah,
I just
but I
need to
got
maybe
you.
practice.
Yeah, it
Okay.
only takes practice. It's very simple. I think once you practice, you will get it. And I think
Okay.
Ron said something. So if it's not Yep, you got it. Yeah, so if they give you this representation, okay, let's reverse it, right? Let's reverse it. They give you this representation and they'll tell you, give us the actual IP address, like the regular version or like the regular representation. So we know here we need a 0 because they need to be 4. They need to be 4, right? So 0, and then we have this does not mean anything. So here we're missing what? 2 zeros. And then here we're missing what? 1, 2, 3, 4. Column 1, 2, 3, 4. And then the rest is the same. So they could give you either or. The question they will give you, it's either or. Either they're going to give you an IPv6 and then they'll show you which one of those representations is right, or they will give you the the shortest version or the abbreviated version, and ask you which one is correct, which one is the regular version. Does the rule make sense? I mean, I understand like
So this whole special thing is for the private ones, like the private address that we just discussed, PIPA?
No, this is just for IPv6. We switched to IPv6.
Okay, okay.
Yeah, so there's 2 types of IPs. There's IPv4 and IPv6. So IPv4, we talked about it, and we said that is we divide it into multiple classes, right? When we said IPv6, when that we talked about it, we said that it's 32 bits. It's about like it's represented in decimal, and then we said it's divided into classes. We talked about all that for v4, and then we talked about DHCP and everything for a PIPA. And then when we got to IPv6, that's when we start. It's the second type of IP. We said it's 128 bits, right? And then we also said it's represented in hexadecimal, right? That's so far what we know about this. And then we talked about the way to represent this IP. It's either this version, or we have something or a way to put it in a short version or in a compressed version by just taking off, by basically compressing the zeros, right? And taking off the leading zeros, right? You guys are good? Let's see.
My question.
Mm-hmm. Thank you breaking up, but I think hopefully it picks up. I'm not sure if it's. Yeah, go. What's your question, Waze? Hey, hey, Waze, do you hear me? I think I lost you.
Yes, I can hear you. Can you
Oh,
hear me?
now I can. Yeah, go ahead. Go for your question, please.
Okay. I said we said that IPv6 is represented by hexa. So now, how many hexas are there? Considering that we have 128 bits for IPv6, and how many bits each hexa contains? Do they contain equal bits, or there is difference between each hexas that we have?
Okay, so good question actually. So to represent in hexadecimal, each one of these is in the you see it's 4 is represented. So okay, so each one of this is represented by 16 bits. So these are 16 bits. So every one of them, right, is 16 bits. So this one right here is 16 bit. The first 2 bits, the first 2 digits that you see in here are represented by 8 bit. Every hexadecimal number is represented by 4 bits. You got it? So hexadecimal is base 16. So base 16. And it's from 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we go A, B, C, D. Right. So this is 6. I'm sorry, there's a 0 missing here. And this is what the hexadecimal represents. They were represented by all these. The A, it's basically an A. The B, it's I'm sorry, the A is a 10, 11, 12, 13, 14, 15. You got it?
Yeah, I got it. So you said each hexa contains 16 bits, right?
It's yes.
So in total, how many hexas do we have?
Hold on, I missed you a little bit. So it's, you said, I think I missed what you're saying. So you're saying it's hexadecimal represents 8 bits?
Let's say in IPv4 we have 32 bits.
Correct.
And there are 4, and it's represented by octa, and there are 4 octas. Each octa contains 8 bits.
Correct.
So the same question if we come to IPv6.
So IPv6 has each one of them. It's represented by 2 octet. So this is 2 octet in here. 2 octet in here. 2 octet in here. Right? So it's basically 2 multiplied by so there's 1, 2, 3, 4, 5, 6, 7, 8. So it's 8. So it's 2 by 8. So it's 16. So it's 16 octet. It's not just 4 octet, it's 16 octet if you look at it as an octet. Every octet we said is 8 bits, and we said every hexadecimal, the way you represent hexadecimal, it's in 4 bits. So every hexadecimal is represented by 4 bits.
Okay, gotcha.
Okay. All right. Okay, I'm gonna do. I'm not okay. All right. Any other questions besides what Waze asked? Okay, so we'll definitely do some practice. I'll bring in a sheet and probably like post it in the portal for you guys to practice, and next class we can go over it. I will send it to Ebenezer, and then he will definitely post it. All right. So next thing I was gonna say, let me see here. Yeah, I see what you said. Okay. So yeah, the next thing we will talk about in here is this IPv6 again. IPv6, the beginning of the IPv6 is what we call the global prefix, right? The global prefix. The global prefix is basically a representation, just like, you know how like the MAC address, like the first digits represents an actual, represents actually like the manufacturer. It's kind of like the same thing, right? So we said the MAC address, the first is 48 bits, right? And we said the first bits, right? The first 24 bits, it's just literally for the manufacturer. So all HP computers or HP devices, their first 24 bits will be the same, right? You guys know what I'm talking about, right? Maybe, no?
I think, I don't know if it's the same.
For the guys that were in the last class, you guys know what I'm talking about at least? No? Nope. Okay. Hi, that's fine. Well, just forget it for now. I'll come back to it since you all probably don't even, you lost. Okay, some of you are lost and some of you are okay, all right. All right. What do you guys remember about MAC address? How many bits is a MAC address?
How many bits in MAC address?
Mm-hmm. Not 8. Not 3, 4.
No idea.
48 bits.
Is it same as IP address, the size?
What's the size of an IP address? It's 32.
It's like 255.
No. Guys, come on. Okay, guys, you gotta remember this very well. And you gotta have to remember these for sure. Like, okay, so MAC address. Okay, MAC address is 48 bits. Okay, you know this by heart. IP v4, it's 32 bits. IP v6, it's 128. Okay. Okay, write it somewhere, please. Write it somewhere.
Should I add that, Retta, to the study guide I made for
Oh yeah,
APOD?
definitely. Yeah, definitely do, please.
Okay, let me add this.
Yeah.
Okay.
Yeah, you got to know this. So for the networking, you got to know the bits because you're gonna be working with them on the subnetting. So if you don't understand what bits each one of them has, you're not gonna be able to subnet.
So I should add this for the networking study guide, for the study guide for when we take this test.
You should have known it on the networking as well.
Oh, okay.
Yeah. So
Okay.
I mean, on the networking section that we did, we mentioned it in there. So let me mute you. Wait, I got you muted. Yeah, yeah, please add it there if you want, and add it on the other. If you want to start networking study guide, that's fine too. But this one we talked about it. We touched base on MAC addresses, if you guys remember, and we said also that in a MAC address, we said that we have how many? We said we have 48 bits, and then we said that the prefix, the first 24 bits, right? It represents the manufacturer, and we said that the last 24 bits represents the actual device. And you know what? Let's find it. Give me a sec. Okay, give me a second. Let's find this presentation. Okay, guys, there you go. This is the slides, right? This is, if you guys recall this. Okay, give me a second. This is the ports. Hopefully I have the updated one. No way. Okay. Okay, you guys remember this? This is the 32 bits that we said for the IPv4, right? Right? This is each 8 bits represents 1 byte represents an octet. Okay? We talked about IPv6 on the network, and we said each two of these. So I wish I can zoom in. You guys can see this, right? Or you want me to download it and open it?
Yeah, we can see it.
Okay, so you see here, 16 bits. 16 bits represents 2 bytes, 8 octet. I'm sorry, 2 octet. So each one of these represents 2 octet. Okay, each one of them, each column, between each column there is 2 octet, which means it's how many bytes? It's 2 bytes and it's 16 bits. Okay. Do you guys understand this part? Like how many bits, how many, the difference between the octet? Okay,
Yes.
yeah. Okay, you all got this. Good. Okay. All right, so at least we can find, I'm trying to find the MAC address and I'm pretty sure it's somewhere here, but I don't know if it's an old version. Okay, so MAC address is 48 bits. I'm trying to find it in here. Here you go. Here you go. This is when we talked about the decimal for IPv4, if you guys recall, and the IPv6. Okay. So in an IPv4, this first 4, 1, 2, 3, 4, these 4, we call them prefix, right? We call them a prefix of the IP. The last 4, it's where I represent the actual IP. Yeah, no, you're good. You're good. Okay.
Is it same in Mac and IP both?
The prefix for IPv6, yeah, that has a prefix. IPv4 does not have a prefix.
Okay.
Uh-huh.
And IPv4, all the 32 bits are the same, so there's no difference, right?
Wait, what do you mean?
By that, I mean that when we say that in MAC address, the 424 bits are the manufacturer, then the rest of 24 is the real IPs. So that sounds doesn't mean anything for the IPv4, right?
No, yeah, it does not mean anything for IPv4.
In half a mile, turn left onto Everfield Drive.
You guys got it?
Okay. Yes, I got it.
Okay, good. All right. So again, this is the shortened expression, if you want to call it. The shortened expression, that's why I told you, there's two rules, okay? So there is something we call the leading zeros, so taking off the leading zeros and removing every 2 blocks. You see that? You can remove the 2 blocks of zeros by replacing them with a double column. Right, so every time you have a double blocks of zeros, you replace them with a double column. Oops, sorry. All right. So just like in IPv4, in IPv6, that we also have some special addresses, just like we have in IPv4. So one of the special IPv6 addresses is the 0, right? So it's typically an address that it's most likely used for configuring DHCP, right? We also have, as you guys remember, we have 127.0.0.1, right? That's for like the loopback. We have a loopback also for the IPv4, right? I'm sorry, v6, right? We have the same thing, so where you can loop back by just putting 00001. That's how you can loop back using a loopback address. All right. We also have something called like the reserve addresses, just like we have for IPv4. If you guys remember those 3, from every class, there is one that is a reserved IP address. In here is the same thing. We have a special addresses, something that what we call the reserve addresses. The reserve addresses are something, basically something that you will have whenever your DHCP goes down. It's the same concepts for IPv6. The only different IPv6 and IPv4. Yeah, the only difference between IPv4 and IPv6, it's IPv6 has multiple. There's multiple IPs that you can derive from an IPv6. You know, so as we increase devices on the internet, we need more IPs. So there is how many devices do you think we have so far on the internet? You know, just one person may have what? How many computers? 3, 4, 5, 6? Not only computers, but devices, right? We talk about like a phone, a computer, a TV sometimes has an IP address because it's connected to the internet, right? So in just a household, a regular household of 4, you may have around what, 20 devices? I'm just guessing, probably 20 devices, right? So an average is 20 IPs. Imagine how many IPs you need in the world. How many people do we have in the world? So think about 20 and think about us being how many billion so far in the world? Like what? Let's 4 billion probably. Multiply that by 20, right? 4 billion to the power 20. Or multiply it, I'm sorry, not to the power 20, but multiply it by 20, right? That's kind of how we're doing in here, right? So we're taking 4 billion, each person has around what, 4 devices, 5 devices, 6, probably 10 devices. As an average, we say that there is over 30 billion devices on the internet as of today, and there's a live website that shows you how many devices are on the internet. So how could you give an IP to every device on the internet? That's the question. That's the challenge that you have. Yeah, not to really mention the companies. Exactly. Yeah. So, you know, not to mention, we're not even looking at the companies that have like exactly multiple devices. What about those servers? Those companies that have servers and those servers are sitting there. How about those websites? How many websites exist? Every website is corresponding to a server, is corresponding to a static IP, right? So how many IPs do we need? We cannot accomplish that with an IPv4. Basically, that's what they created IPv6. IPv4 and v6 were created at the same time, but we were using IPv4 for a long time. But then it's coming to an end because there is no more IPs to give away to devices, right? So as you can think about it, will there be no? IPv6 has trillion of IPs. Think about it, it's 128 bits. You know, it's 2 to the power 128. I'm not sure how much is that. Yeah, so 100, I'm not sure what's 2 to the power 128. It's what, I'm not, yeah, so okay, so she got it. Yeah, so it's 304 billion devices that you can have.
So is there any,
excuse me? Yes, Wes?
so is there any plan in the technology world that they're going to come up with another IP like apart from IPv6?
No, they don't need one because IPv6 will cover every device. So far, we have 30 billion devices in the world. What, you're gonna double it probably? You know what? triple it, it's not going to affect anything because you have 3 or 4 billion devices, like Tercy just mentioned. So it's already covering everything. You don't need more. Okay, so that's why they created IPv6. IPv6 was created because we are coming to an end with v4. We consumed all the v4 devices we have. Now, as you can see, every device has a v4 and a v6 associated with it. Every device, every host, it has both of them. Why? Because they're preparing us, they're preparing the internet to, to open up to IPv4. It's about time to start IPv4. There are no need to repeat IPs. Yes, there's no need because we already have an IP. Yeah. So, and subnetting was created in a way, and as you guys are going to see when we start talking about subnet was put in place in order to use more, to take care of all these IP addresses that we have in place. So because we were running off IPs, that's what we started subnetting the IP, because subnetting is basically segmenting the network. Okay. So what is this? What is the subnet? Who can tell me, like, when you go to buy, when you go to Verizon and they give you a actual network, they give you a router, what is associated with that router? It's an IP address. Okay, so there's one IP address associated with the router. How could you, from an IP address, one IP, generate all those IPs that's being assigned to your house? How do you do that? Did it ever cross your
You
mind?
do subnetting.
It does subnetting, yes. No. Assign an IP. Okay, let me see that. Yeah, it does subnet when you're in a router. Assign your personal. Yes, they're not. Yeah, so all the IPs within your, within your router are internal. That's right. That's correct, Maro. So when you purchase a router from the ISP, Internet Service Provider, it comes with an IP. That's the gateway IP. That gateway IP, it's only assigned to you. Okay, it's not going anybody else. And everybody inside your network has a different IP, but once they go outside your network, when they go to the internet, they go with one IP, which is that default gateway IP that was assigned by your ISP, by your Internet Service Provider. So that's kind of like, right? Yeah, good. I think you guys are like catching it. Any questions about these before we move on to the next thing? Yeah, it's gonna definitely click. Like little by little, it's gonna start making a lot of sense to you guys. You just don't give up on it. Just keep going step by step. Push the information through and understand it. It's all about understanding the whole thing. You gotta understand. You can't just, you can't just like, oh yes, it's for example, if you question everything, that's what I wanted to say. Question everything. Question things how they work. Because once you understand how things work, you're gonna start understanding the concepts. So because when you go, for example, I can ask you the question. So how does the router go outside with one IP? What protocol do they use? And start questioning things. How does my router assign IPs? Right? How does he assign an IPs? What is those IPs coming from? What is all those subnets coming from? Right? You start questioning things, you start understanding them. Okay, the best way to understand things is if you can explain it to your kid. If you can explain it to a 5-6 years old how things are, how things work, trust me, you're gonna succeed. Because I would rather not. Oh gosh. Yeah, well, I mean, my professor used to say that, so I kind of like adopted that sentence from him. I don't know how it is to explain it to a 4 or 5 years old, but he used to tell us that. All right, so we'll go to one last topic, I think, and then we'll probably wrap up tonight. And again, next Tuesday, I'm not gonna start probably subnetting. I'll still talk to you guys. We'll have probably some hands-on. That's not it. Yeah, so we'll have some. It's like that's not easy. Yeah, so we'll have some hands-on, and then afterwards we will actually do. I'll start just talking about converting IPs, just like we did. If you guys remember for A plus, I'm not sure how many of you guys remember. We used to switch from decimal to binary, right? So that's what we're gonna do next class. We're gonna go decimal to binary and cover a couple more topics, probably a couple like routing topics and things like that. And then on Thursday night, we will start talking about subnetting. Okay, we'll start the math. It takes a little bit of math actually, to be honest. So yeah, just be ready. Yes, by division. How long does the course be? So the course is only like 5 weeks or 6 weeks in total. Yeah, so it's shorter, but there's only 5 sections. And the only hard thing that you will have is subnetting. That's the only hard thing. And it's not even hard. It's just literally you need to practice. You need to practice and practice, and do so many because it's not all of you guys will get it at the same time. So it's kind of like some of you guys will take longer than others. But that's the only thing. The others, like you see, like somehow I think I kind of as we go through IPs and stuff like that, you already know stuff. You need to highlight stuff. For example, you need to know how many bits each thing is. Okay, and why I went through that, and I'm trying to, I kind of like probably sounded a little mad about it, I guess. But it's basically because it's gonna be a foundation of networking. You need to know how many bits on each thing is. Now, like as we went through A plus and we did like a highlight of all the topics of everything. Now we came to that point that you need to do a deep dive into things. Okay. All right, so we're gonna go over the OSI model, and again, this is a quick review for the folks that, for you guys, I think 4 of you or 5 of you guys that were on A plus. This is kind of like a review for you. It shouldn't be any harder. So what's an OSI model, right? OSI model is basically a model of how the communication between hosts happen. It's just an architecture, and it's like I said, it's like a model that explains to you how the inner network or interconnection works, right? The advantage of this model is basically just major thing is just making sure that we can divide the network, divide the communication into layers. And so if there is an issue with the communication, we could divide it, and then as we look at each layer to find if there's any faults and how to resolve it per layer. Okay, the OSI model, again, it's 7 layers. We talked about physical, data link, network, transport, session, presentation, and application layer. All these layers, each layer, there's something that functions on top of it, right? So when we talk about physical, we talk about cabling, right? When we talk about data link, we talk about MAC address and switches, right? We talk about network, we talk about routers, and we talk about IP addresses. We talk about transport, we talk about TCP UDP, right? The transporting protocols that we have. Session, right? It's basically a control. It's like that's how you open up between 2 devices. You open up a session, you establish a session, and then presentation, it's the layer where a lot of the encryption happens, right? When you do data encryption, data compression, and you exchange keys on whatever encryption you're trying to apply in there. And then we have the application layer, which is, your Word document, any applications that you can think of, it's basically in there, right? All right, so we're gonna talk a little bit about, I don't wanna really just, sorry, here. We're gonna talk a little bit about the upper layers and what type of, what do they provide? So we have the session, presentation, application. Never read the OSI model from the top down, always bottom up, okay? So session, presentation, application. So the session, basically, it's what established that link, you know, the links between those two applications that are trying to communicate. The presentation handle like always encryption. Every time you think encryption, think about presentation. And the application is the user interface. It's the GUI, which we see right here in front of us. If you see Windows, you know, if you see Microsoft, if you see Adobe, if you see right now what we're looking at, I forgot, it's Zoom. That's an interface. Okay. The lower layer, this is kind of like that dirt, right? The physical layer, it's the wires, right? The wires, the cables, the voltage, the, you know, all that, you know, the current, everything. The data link, we talk about two important things. We talk about switches, and we linking them with a MAC address. Okay, so we're combining the MAC address with the switch. Network, we're putting routers with IP addresses. Transport, we're doing what? We're creating two main protocols that we had at this layer, UDP and TCP. One of them we said is reliable. The TCP, we have a whole section that we're going to talk about TCP, UDP, and the three-way, the handshake protocol. We're going to talk about it in another section, but TCP, UDP are the transport protocol that we use. Okay, reliability. So reliability, and again, acknowledgement comes at the TCP model, right? When we talk about the TCP, we said it's reliable, it's connection oriented, right? So connection oriented is reliable. Reliable, why? Because it does something called an acknowledgement. An acknowledgement, what it does is whenever I send data, I acknowledge that I received the data before I keep, I'm sorry, before I continue. I mean, I can continue sending, but I'm always acknowledging data. If I don't acknowledge, the sender will resend the data. That's unless UDP, okay? UDP does not have that. So this is a connection oriented. So the sender, the receiver, so the send the sync. This is what we call a three-way handshake. I send the sync and synchronized number. You send me back the synchronized number, like associated with acknowledgement number. You send it to me, I send you back the acknowledgement number, and then the data has been transferred. Right, so this is kind of like the data flow. So you send me data, I received it, but there is an acknowledgement in between them. Right, so I send the data, I received it, I send you an acknowledgement, you send me the data too, I receive it, I send you an acknowledgement, and it keeps going like that. Now, look, I send data 1, 2, and 3, and 4, and then I acknowledge, right? But I never acknowledge 3. Right, so if you don't acknowledge the data, so the sender sends 1, 2, 3, 4, 5, 6, and the receiver has to receive 1, 2, 3, 4, 5, 6. If the receiver did not receive 3, he received everything, but he's missing 3. He's not gonna, when the sender keeps sending until 6, and he sees that the receiver never acknowledged 3, he will resend 3. See that? Look, I sent 1, 2, and 3. And I acknowledged 4. I acknowledged them, right? Now I sent 5 and the data got lost, right? So I never acknowledged it, right? The acknowledgement of 5 never came in, so he sent 5 again. You see that? So what happens in here is whenever there is this three-way handshake, this thing needs to happen in between them in order to work, in order to make sure that the connection, in order to know that the whole data is being transferred. Okay, so this thing right here, this three-way handshake established that connection. So if I don't send that synchronization and then synchronization with an account number, it's just like saying, hey, I'm gonna start counting. We're gonna start counting from 0, or hey, we're gonna start counting. I'm gonna start counting from 1. So we established that in here. We established the sync and the account at the three-way handshake between them. Then the connection is established. Then they start sending. Everything you send, you need to be acknowledged. This is only difference between TCP and UDP, right? We're gonna talk about routers, and I just want to explain a little bit. Every time when we talk about routers, I want you to understand one main thing. Routers are always associated with a routing table. Every time we talk routers, you talk about routing table. When we talk about switches, we're talking about MAC address table. MAC address. So we have a routing table and we have a MAC address table. So this is like a routing table. And the data link, we have a MAC address table, right? A MAC address table on the routing table, they're associated with devices, hardware, the switch and the router, okay? The word encapsulation and decapsulation. Encapsulation is putting something into something. So all these goes one into one, then to the physical layer. So we encapsulate them. So we take the data, we add a TCP header. We take that data again, this whole data, and we add an IP header. We take the whole data again, and we add a LLC, or what we call a MAC header. And then we get to the physical layer, which is the bits. Basically, every layer in here in the OSI model, the data is called differently. So we call it bits at the physical layer. We call it frame at the data link layer. We call it packets at the network layer. And we call it segments and at the transport layer. The term encapsulation is just putting data in, it's basically adding something to the data. So I take this data and I add something, some type of headers to it. Okay. Any questions about it? Any questions about the OSI model or about anything we covered today? Let me see that. You had a good encapsulation. Slide on A+ course notes. Yeah. Yeah, there is I'll probably move it here for the encapsulation. I think that's what we talk about you know, the airplane and thing like that. But you gotta have to be familiar, guys, with the terms in here, okay? So these terms, you need to be familiar what the data means. So when they tell you, hey, we've been sending packets, you need to know that they're talking about the network layer. When they say I never received this frame, you need to understand they're talking about what layer. So as they talk about the type of data, they're talking about a certain type or at a certain layer. So you need to be familiar with the layer that they're referring to. Okay, that's also a keyword in here. All right. Any questions in general about anything that I covered today? Any questions about anything in general? Not only this, but if you have any other questions that you want to mention. I got thirsty. Any questions?
Can you give us by example?
Go ahead one more time. I heard can you, but I didn't hear the rest. Wait.
Yeah.
Yeah, I couldn't hear you. I'm sorry. Could you have to repeat it?
Can you differentiate? Can you differentiate? Yeah, can you hear me?
Yeah, I can hear barely, to be honest. Go ahead.
Okay. My question is that
can you
differentiate between TCP and EDP?
Yes, yes. So in what? You said,
for example, what kind of example?
Oh, yes. I got what you said, I think.
For TCP,
sorry.
and what kind of example can be UDP?
Yeah, TCP trusted, yes. So yeah, TCP, it's being used, so UDP is being used in streaming. For example, if you're gonna stream like a football game, right? If you're gonna stream in a football game, you just keep sending data without acknowledgement because you don't care. Like if you're in a video game, you're not gonna stop the video and say, hey, yeah, I didn't acknowledge this frame or this bit. Let's resend it. They don't do that. They just keep sending. If you see the game, sometimes it freezes and then it continues. Yeah, it freezes. It missed some packets and it continues. right? That's kind of an example of UDP. UDP is unreliable, like Fana said, it's unreliable. It's not like you can't trust it. You don't get any acknowledgement. TCP is reliable. It's like it makes sure that the data is being submitted, right? TCP, every website has TCP, does not have UDP, right? Everything normally has a TCP layer because they want to make sure the data is being received, right? Unless UDP. UDP, it's basically does not acknowledge that the data is being received. It does not do any checks. It just keeps sending data. It's a stream of data compared to TCP. Does that make sense or?
Yeah, it's fine now. I got
Good.
it.
Yeah. Okay.
So
Great.
all those websites or
TCP.
applications that goes live stream. So
Oh,
that's
those are
UDP.
UDP. Yes.
That's
Those are
UDP.
UDP. Yes. Yep. That's right. That's right.
But for TCP, there always needs an acknowledgement.
Acknowledge. Yes. Yes, sir. Yep. You got it.
Thank
All
you.
right. Yeah. You're very welcome. You're very welcome. Yeah, so that's pretty much everything we're gonna cover today. I think we're still on that first section, just FYI. Tomorrow, not tomorrow, sorry. Next week on Tuesday, we'll finish the first section, except the subnetting. Subnetting is part of the first section, by the way. We're gonna cover the rest of the section, right? But we're not gonna get to subnetting. I'm gonna start subnetting by itself separately. I'm gonna talk tomorrow. Next week, I will, I will be talking about the actual, how to convert from from decimal to binary, okay, and from binary to decimal. And I know we did that class before. I would encourage you guys to review the class. If you can access the recording, please go ahead and watch that recording. And then I'll do some practice in class so you can get familiar with that. And then we'll talk a little bit about the we'll finish the section, right? And then Thursday we'll start subnetting. We'll spend one class or two classes on subnetting, and then just continue on the slides. And then if we need more practice on subnetting, we'll set up some classes in parallel for that. Okay. All right. I think that will be all for today. Let me stop sharing actually, so I can go back here and